Hello and welcome YCLs. This is SS Tripathi welcoming you to my channel. This time we shall be discussing the fourth example of redox and non-redox reaction. In the last video we talked about oxidation number concept in details. So that will not be repeated anymore, and we shall be focusing on several examples of reactions belonging to only two types, redox or non-redox. Let us take two examples. One for redox, the other for non-redox. So we'll be doing for many more videos, we'll be taking off examples. So in this case, the iron reacting with water, a red hot iron reacting with superheated steam to give you the magnetic oxide or ferric oxide about which I was discussing, plus hydrogen. So iron will be able to displace hydrogen from water on a very stringent conditions. That means very hot iron, very hot iron, superheated, and this will be a superheated steam. Then only the reaction will occur. We can very easily balance by heat and trial method. It is 3 iron, so we multiply here by 3 and here 4 oxygen by 4. There are 4 hydrogen molecules, then 4. So this is a very simple balance by heat and trial. So I have told you that Fe3O4 is nothing but equimolar, 1 mole of FeO, 1 mole of Fe2O3, ferrous oxide, ferric oxide. And together if you add them, it will be Fe3O4. And iron is oxidized from 0 because rule number 1 says that if it is in the neutral uncombined state, it is 0. And here, may it be average, the average oxidation number is plus 8 by 3. So while explaining the equation, you have to give average. We know for sure there is nothing called 8 by 3. One of them is plus 2, two of them are plus 3, but you have to write once the average value. So it is increased. So this is oxidation. And once there is oxidation, loss of electron, there has to be gain of electron. So hydrogen is in the plus 1 state in water, and it goes to the neutral 0 state. So here the oxidation number is decreased. This is a reduction, right? So this is the redox reaction, and here you heat a metal. Here the iron metal is taken, and here water soaked in a glass wool. Then when you heat it, then it will release the superheated steam, and the iron is also very much heated, and they will react to produce hydrogen, which will be collected by the downward displacement of water. And you know how to test hydrogen. If you just put a glowing matchstick, it will burst, what we call pop sound, and that pop sound that will indicate it is none other than hydrogen gas, right? Now let's see this case where I have borrowed from chemistry practical video, where you find
of the delivery tube.
This is iron, and this is a glass wool containing water, which will produce superheated steam, and they will react, and hydrogen gas will be collected here. In a very simple manner, the scientists have, collected by the downward displacement of water in a test tube, and he will study the existence of hydrogen by putting a matchstick, glowing matchstick, which will produce a pop sound.
There's not really very much reaction.
He has left out the
obvious with the iron
gas, because the first gas expelled out is air. When all air will be expelled out, then there will be hydrogen that will come.
Slower than the zinc. So that
it's a very slow reaction, of course. It's a reversible reaction. So he will study the property by putting a matchstick, glowing matchstick.
So again, we're going to do the test just to prove that there's hydrogen there. So you'll see me stop with the test tube there, and then we'll check that the hydrogen pops. So again, the word equation, iron reacts with hydrogen oxide, steam, it gives us iron oxide, and then watch
And
and
there
see
will
if
be
the
pop
gas
sound,
pops
there will
to
be
get hydrogen.
the
Yeah,
pop,
so
yes. And it will burn
hydrogen. So
also. It will
iron plus
burn.
hydrogen oxide
Not
gives
this
us
one. This
iron
one is burning,
oxide,
but this one will
and then
burn.
the
Now
gas
see,
that pops
burning.
there, hydrogen.
So that is a redox reaction. But we shall take up another example of a non-redox reaction where quicklime, which is calcium oxide, when reacts with water, it forms calcium hydroxide. Simply, the oxide changes to hydroxide. When it dissolves, it reacts with water and the formula changes. Calcium oxide becomes calcium hydroxide. And it is a highly exothermic reaction. A lot of heat will be involved. You will find so much heat will be involved that the water will boil. So bubbles of water vapor will come out. Don't confuse that bubbles as hydrogen gas. There is nothing hydrogen gas will be involved. If you can collect that vapor, you can't get a pop sound by lighting a matchstick. So this is what we call the quicklime, and this is the slacklime, right? And also see how exothermic reaction here. This is quicklime, calcium oxide powder, we added water, and also there is a surrounding water too, so this water will also boil. So these vapors are not hydrogen gas, these are water vapors. So the calcium oxide powder is converted to calcium hydroxide, looking like chun, as we call in Indian Hindi language. So a lot of heat is produced. So that is, and this is attributed to Pomatine channel. Thank you for that. And we come to the end of this video. Once again, the bottom line is there are two types of reaction, either redox or non-redox. Don't ever study the chemical reactions in a foolish manner, but in an intelligent manner, as a fun with a logic. Have you subscribed to my channel? If not, please do so. And we'll be having a regular series of videos. Continue to watch and subscribe to my channel. Bye-bye.